Welcome students. Welcome for online lecture on fluid power systems. Students, we are going discussing first module, that is introduction to fluid power systems. So in this session we will discuss contaminants. Contaminants, the worst enemy of these precision made components of hydraulic system is the contaminations in fluid, which may be both solid and liquid. The solid contaminants are dust, dirt, worn out metallic pieces, and other particles. And the liquid contaminations are like water, acids, paints, etc. These contaminations are undesirable in the hydraulic system and therefore need to be arrested. There are different causes for failure of hydraulic system, and majority of them will be due to solid particle contaminations in the oil. Sources of contamination. Contamination may be classified as built-in metal chips, welded scales, lapping compound, sand from casting, or debris reduced during the manufacturing process. Some are system generated, where products generated inside the mating components may be categorized here. Some are maintenance generated, contaminants generated by opening and closing of a system and exposed often to dirty maintenance environments are examples of maintenance oriented contaminations. The new fluid added to the tank during filling up operation is also another source of contamination. Contaminants during assembly stage. Pipe scale from pipes not cleaned before assembly. Corrosion or rust from ferrous metal components stored in unfavorable condition. Sand residue, foundry sand on castings. Lints or fiber threads from cloths used for plugging or cleaning components. Swarf produced by incorrect assembly tools or technique. Adhesive particles from surplus adhesive or joining compound used on gaskets or static seals. It is most important that care should be taken to ensure correct and clean assembly before a system is put into operation. So it is important that to ensure that correct and clean assembly. So the surface where we are going to keep all the components, that must be clean. So it has to be maintained clean and clean before assembly a system is put into operation. Before a system put into operation. Contamination during service. Once in service, likely sources of further contaminations are produced. Example, metallic particles. Besides being harmful because of their abrasive and blocking characteristics. Finely divided metal can act as a catalyst, promoting early breakdown of the fluid. Metallic particles are very likely to be developed in a new system due to initial pump wear. After a suitable running in a period sets in, the wear rate of pumps and other mating parts gets reduced due to lubricating property of the fluid. Paint flakes caused by the failure of old paint on the inside of the tank or paints which are not compatible with the fluid are also quite harmful. As the machine continues to operate, moving parts naturally begin to wear and generate dirt. Therefore, every internal moving part in the system can be considered a source of future contamination, especially during the machine breaking in or running in period. Components housing continually experiences hydraulic and mechanical shocks due to constant flexing from normal stresses and pressures. Some other contaminants are acidic byproducts. This is mostly caused by process of oil oxidation. sludge. This is also caused by oxidation and fluid breakdown. Elastomeric particles. This is generated from seal wear. Airborne solids. They are inducted through the tank, joints, piston surface, etc. when leakage of oil takes place. Damage due to solid contaminants. So what are the damages caused by the solid contaminants in the hydraulic system? So blockage of valve. So there may be blockage of the valves due to the contaminant solid particles which are present. So it will stop or it will slow the oil flow. Jamming of pistons and spools. The moving parts inside the valves, or it may be actuators, it will not move correctly. Uncontrolled and increased leakages. So there may be leakages, internal leakages due to scratches formed by the contaminants on the moving surfaces. So the oil is going to pass from one side to another side. That is known as internal leakages. Change in control characteristics. The speed which is required we are not going to get. It may increase or it may decrease. Ultimately, components of system failure. So there will be failure of the components due to the contaminants. When scratches are formed on the spools or pistons, so there may be leakages and there may be power losses. So the components are going to fail. Heat exchangers. So why the heat exchangers are required? So heat exchangers are required to control the temperature of the fluid. Temperature of the working fluid also influences the performance and hence efficiency of the hydraulic system. Excessive heat hastens the oxidation of the fluid and reduces its viscosity. This leads to deterioration of seals and packagings and accelerates the wear between closely mating parts such as valves, pumps and actuators. Similarly, low temperature of the fluid increases the viscosity, resulting in loss of power, poor response of the fluid. Significant source of heat includes pumps, pressure relief valves and flow control valves. Hence, temperature control is an important factor to be considered to maintain the performance and efficiency of the hydraulic system at its maximum level. Temperature control can be achieved using heat exchangers. Although design and circuit has considerable effect on the fluid temperature, heat exchangers are sometimes required to maintain the operating temperature, which is critical or when the system cannot dissipate all the heat is generated. The three common types of devices used for maintaining the operating temperature of the fluid are heaters, air coolers, water coolers. Heat is generated in hydraulic system whenever oil flows from higher to a lower pressure without doing mechanical work. This means that if a relief valve is allowing the oil to flow back to the tank and system pressure is being maintained. Pressure losses may occur when oil flows through inadequately sized valves or pipes or sharp bends in hoses and tubes. An easy way to dissipate heat is to use a reservoir sized large enough to dissipate heat generated in system. Higher temperature reduces the viscosity of the hydraulic oil, allowing greater internal leakages and damage the pumps and increase the oil temperature. Even this may further eventually destroying oil. So already we have discussed type of heat exchangers. It may be heaters or air coolers or water coolers. It may be parallel flow, it may be counter flow, it may be cross flow. So in major types of heat exchangers, we are going to use the air cooled heat exchangers. Oil to air cooler. Oil to air cooler, that is this figure shows the cross flow type. So hot oil in and cool oil out. So the air which is passed cross flow type. So it will take the heat from the oil and oil is cooled. This is one type of the heat exchanger. You can use parallel flow or counter flow or cross flow type heat exchangers. So this is another type of heat exchanger, counter flow type. So you can see the hot oil in and cool oil out, and counter flow there is a air flow. So problems in the hydraulic system. So various types of problems are arised in the hydraulic system. So following are the some: variation in speed of actuator, loss of system pressure, steep rise in oil temperature, slow response to control, non-uniform motion of the components, excessive leakage in the system, no delivery or reduced delivery of the pump, no output or reduced output of the actuator, sharp noise in the system. So these are the some problems which may arise in the hydraulic system. Hierarchy of failure rates of some of the common hydraulic elements. So first is common element, that is valves. So maximum times the valves are going to fail. Pipes and next the pipes and reservoirs, next actuators, next hydraulic pumps, and lastly it is the prime mover. Most of the problem in the hydraulic systems are due to the three hydraulic energy parameters. The three parameters are flow of fluid, pressure of the fluid, and temperature of the fluid. The incorrect flow. There may be no flow or low flow or excessive flow. Flow of the fluid is a prime importance in the hydraulic system. It is always necessary to maintain the correct and designed flow so that the system operates at its peak efficiency. Three situations may arise, that is no flow, low flow, and excessive flow. So what are the reasons for no flow? A pump not receiving the fluid. It may be a pump not receiving the fluid, prime mover not operating, prime mover pump coupling not transmitting power or disconnected or broken down, direction control valve set in the wrong position, entire discharge from pump passing over relief valve, damaged pump, pump not receiving fluid. So why the pump will not receive the fluid? Either due to the leakages, the level of the oil might be gone down below that pipe, suction pipe. Due to that it will not suck the oil. That is the reason. Prime mover not operating. Prime mover, pump cooling, pump coupling not transmitting power or disconnected or broken. So it means when you start the power electric motor, it is not transmitting power to the pump. Direction control valves set in wrong position. Entire discharge from pump passing over relief valve. So the oil which is pumped by the pump, it is directly passing through the relief valve and again it is going towards the reservoir. It is not flowing in the system. And another reason may be damaged pump. Low flow situation may occur due to the following reasons. Flow control set too low. So flow control valve set too low, that's why the flow is less. Relief or unloading valve set too low. Flow bypassing through partially open valve. External leakage in the system. Speed of motor incorrect. Defect in motor, it may be a defect in pump or defect in a valve or defect in a cylinder or other elements. So these are the reasons for low flow. And what may be the remedies? replace dirty filters, replace the part, check for damaged pump, motor, align coupling properly, adjust flow control valve, check the control of valves, replace the part, tighten inlet connections, remove air from the system. Excessive fluid flow may be due to flow control valve set too high, so you must adjust correctly. Motor driving at higher speeds, replace motor or reduce the speed of the motor. So excessive flow may be due to flow control valve set too high, means you must adjust the correct flow by flow control valves. Motor driving at high speeds, due to high speed of the motor, excessive flow of the oil will take place, so replace motor or we must reduce the speed of the motor. Improper pump size, replace with correct size pump. Pressure, another parameter responsible for desirable functioning of hydraulic system, is pressure. Any force or torque related functions of actuator, cylinder and motors depend on correct pressure of the fluid. Any force or torque related functions of cylinder and motors depends on correct pressure of the fluid. Incorrect pressure may lead to force or torque related or load and work related problems of the actuators. Incorrect pressure may be no pressure, low pressure, high pressure and erratic pressure. Why there is no pressure? No pressure situation may be due to no flow of fluid. Low pressure may be due to existence of pressure relief path. Setting of pressure reducing valve too low, that may be the reason. Damaged pressure reducing valve, damaged prime mover, pump or cylinder. What are the remedies for low pressure? Proper adjustment of pressure reducing valve. You must adjust pressure reducing valve correctly. Cleaning of filters has to be done. Cleaning of reservoir and pipelines. You must prevent the leakages. Replacing the parts and elements. Worn out parts has to be replaced. So these are the remedies for low pressure. High pressure. In this case the pressure of fluid is very much greater than the required. The reason may be improper adjustment of pressure valves, worn out or damaged valves. Remedy: adjust or replace the valves. You must adjust the valves or you must replace the valves. So erratic pressure, if the pressure of the fluid is not equal to the set or designed pressure and fluctuate between the required pressure, then it is called erratic pressure. There is a fluctuation, that is known as erratic pressures. Erratic pressures may be due to air in fluid. Due to the air presence in the oil, there will be erratic pressure. There will be increase and decrease of the pressures. Worn out relief valve, due to worn out relief valve also erratic pressure may take place. Contamination, due to contamination in the fluid, worn out motor, pump or cylinder. So what are the faulty operations? The faulty operations are no movement of the actuator, slow movement of the actuator, or there may be fast movement of the actuator and erratic movement of the actuator. So no movement, the actuator becomes motionless due to following reasons: no flow or pressure. Already we have seen why there is no flow and we have seen the remedies. We have seen the just now discussed why there is low pressure, high pressure. So the actuator becomes motionless due to the following reasons: no flow or pressure, no flow or no pressure, misadjusted or inoperative devices, worn out or damaged actuator, inoperative servo valve, etc. Why there is a slow movement? Slow movement of actuator may be due to low flow, too high viscosity of the fluid, insufficient control pressure of our valves, no lubrication for guideways and leakages, worn out or damaged actuator. So these are the reasons for slow movement: low flow of oil, too high viscosity of the fluid, insufficient control pressure for valves, no lubrication for guideways and linkages, worn out or damaged actuator. So we'll see the reasons for high speed. High speed is the more than desirable or designed speed. High speed may be due to high flow, malfunctioning of servo amplifier, overriding of the workload. What are the remedies for that one? The proper maintenance of fluid temperature is necessary, proper maintenance of fluid viscosity is necessary, use of correct lubrication and efficient lubrication is system, overhauling and replacing the worn out actuators, parts, etc. Flow problem. Pump not receiving fluid, coupling not transmitting power, damaged pump, flow control set too low, external leakages, speed of motor incorrect, flow control valve set too high, motor speed very high, improper pump size. So these are the flow problems. So problems for high flow or no flow or low flow, pump not receiving the liquid or oil. It may be due to the coupling not transmitting power, damage. It may be due to damaged pump. It may be due to flow control set too low, due to external leakages. There is a flow problem, speed of motor incorrect, that's why flow problem will occur. Flow control valve set too high, that will also make the flow problems. Motor speed very high, the flow will increase, so there will be excessive flow. So to reduce the excessive flow, change the motor or reduce the speed of the motor. Improper pump size. So if the pump size is not correct, the flow may be low also, it may be high also. So you must select the correct size pump. Pressure problem in system. No pressure is due to no flow of fluid. Low pressure is due to setting of pressure reducing too low, damaged pressure reducing valve, damaged pump, improper adjustment of pressure valves, damaged valves, air in fluid, worn out relief valve, contamination in fluid, clogged filters, worn out pump motors. Faulty operations are due to no flow of pressure, damaged actuator, inoperative device, low flow, too high viscosity, insufficient control pressure for valves, high flow, overriding of the workload. So once again we will see the working. There is reservoir, filter. Already we have seen different types of filters, and we have seen the various parts of the reservoir, the pump, what are the problems of the flow. So pressure relief valve, next direction control valve. So from direction control valve, next the oil is going to flow to the actuator, and after doing the work in the actuator, the oil is going to return back to the reservoir. And there are three positions of the direction control valve. In one position the cylinder is going to extend, in one position there is no movement of the actuator, and in third position it is going to retract. Energy loss. When the hydraulic oil flows through a pipe or a fitting, a portion of its energy is lost due to pipe friction, leakage, etc. It has been found that higher the viscosity of oil, greater the loss of energy. Again, lesser the oil viscosity, higher the leakage losses. Oil energy is also lost due to presence of various types of valves, pipe fittings, etc. Tees, elbows, etc. The nature and art of flow path and orifice design determines the amount of loss through them. Losses in pipes. The resistance loss in a pipe can be calculated by using various empirical formula developed. Applying the same in the Bernoulli's theorem and continuity equation of pressure drop due to resistance can be calculated. The head loss in the straight pipe is determined by the following equation. HP, that is head loss in meters, is equal to lambda, that is friction coefficient, into mean velocity of the oil into length of the pipe in meters divided by 2 into g into d, where g is acceleration due to gravity and is inside diameter of the pump. So by using the formula you can calculate the head loss in the meters. So remaining things we will discuss in the next class. Thank you.